In this section, we're going to be talking about a little bit more about scientific notation. We're also going to cover unit conversions briefly and then talk about sig figs. So when you're calculating with scientific notation, this is basically if you don't have a calculator or for whatever reason you don't think that your calculator is giving you the right answer. This is a way that you can kind of check to make sure that you're getting the correct exponent with your scientific notation. So when you multiply two numbers in scientific notation, you'll actually add the exponents together. Okay, and then you might have to readjust the scientific notation based on how many numbers are to the left of the decimal point. So if you do your multiplication and you end up with 12.546 times 10 to the, let's say, 4th, okay, you would have to readjust that, okay, because scientific notation, remember, can only have one number to the left of the decimal point. So that would be 1.2546 times 10 to the 5th, okay? You will have to modify your exponent in that case. And then if it ends up being a number less than 1 with your exponent as well, then you would just, move the decimal point the other way and then take out a number from the exponent. So as you can see here, this is actually with division. So division is incredibly similar. It's just instead of adding the two exponents together, you subtract the two. And the thing to remember with this is that whichever number is on top, okay, so it's being divided by the other number, that's the number that comes first. Okay, so you can see in this example you have 4.5 times 10 to the 12th being divided by 3 times 10 to the 8th. Okay, so because the 4.5 times 10 to the 12th is on the top, it's going to be 12 minus 8. Okay, and again, this is something that I will show you actually how to do this in your calculators in class. So this is more of a kind of in case you want to double check your math or make sure that your calculator is working correctly. Using this, you can kind of tell where the number should be, like a kind of range where the number should end up. And obviously I don't know where that came from, but all right, unit conversions. So with unit conversions, oftentimes you have to deal with what are called conversion factors. So conversion factors are just numbers that relate to different units. So you've probably heard several of these, even if you didn't know what they were specifically called. So if I say how many inches are in a foot? 12. Okay, so that relates inches to feet. So you have 12 inches equals 1 foot. Right? And you get these with, if you do cooking, cups, ounces, pounds, all of that. You see this with miles per hour. That is actually a unit conversion factor. Okay? It's how many miles in 1 hour. Right? So you see this a lot more than you probably realize. So it's always written as one unit divided by another unit. Okay, whenever you're using them as the conversion factors. So they can be flipped as needed. So if you have, say, we'll go back to the inches and feet. Okay, if you have 12 inches over 1 foot, okay, so it'd be 12 inches divided by 1 foot, that's your conversion factor. You can also flip it to be 1 foot divided by 12 inches. Okay. Okay, so, well, this is talking about with the metric system. Metric system, it's a little bit easier to convert between different units simply because you have the King Henry died by drinking chocolate milk here. Okay, so in this case, you're converting from milli to hecto. So you find milli on this little mnemonic device, sorry. So milli is down here, and then you have hecto, which is all the way up here. So then you count the number of places. Okay, so 1, 2, 3, 4, 5. Count the number of places between the two prefixes that you're using. So it is 5 places, which means that you're going to move the decimal point 5 places. Okay, it's easier to see it when you write it out like this, in this format. Okay, so we've got milli here going to hecto. Move the decimal point 1, 2, 3, 4, 5. And the direction that you're going, that you're moving on this scale here, is the direction that you'll move your decimal point. So you move it 5 places to the left. And that's how you can convert in metric really easily. It's one of the reasons why scientists use it so frequently, because you don't have to worry about having, I think it's 0.254 centimeters in an inch or something like that. You don't have to worry about that. It's all factors of 10, so it's really easy to move everything around. Okay, and this is going back into the scientific notation. Your base is obviously going to be 10 to the 0, and then deca is basically times 10, that base times 10, so it's 10 to the first, and then so on and so forth. You also have a couple extra prefixes here. So we have mega, okay, which is times 10 to the 6th. And then on the other end, we have some funny looking ones. So this U is actually a Greek letter, okay. In this case, it stands for micro. And then you have nano. Angstrom is a very particular one. It is German, which is why you have this little circle above the A. Angstrom is important because it's actually the scale that atoms are at. Okay, so if you have an angstrom, it's 10 to the negative 10th of a meter. Okay, so that's why that one's thrown in there. But for the most part, you'll see that once you get outside of these major ones here, from kilo down to milli, okay, it jumps by a factor of 1,000 instead of 10. Okay, so it's instead of 10 to the 3rd, it goes up to 10 to the 6th. And then down here, it goes from 10 to the negative 3rd down to 10 to the negative 6th, 10 to the negative 9th, and then 10 to the negative 12th for pico. Okay? And there's that again. I'm not entirely sure what it's doing right now. But continuing with this, I always say that the easiest way to get your unit conversions correct is to determine what units the answer needs, figure out what units you have to begin with, and then line up your unit conversion factors until all of your units cancel till you get the final units that you need for your answer. Okay, so if numbers confuse you, I find that the easiest way to do unit conversions is just to ignore the numbers at first. Only focus on the units and line the units up so that they will cancel. So you have, say you're doing inches to feet, okay? If you're given inches, you have inches on top, that's what you're given, and then your unit conversion factor needs to line up so that you have inches on the bottom, because then it's inches divided by inches, and those cancel. Okay, and that would just leave you with whatever's on the top, which in this case would be feet. All right, so if you line up your units, you will get these unit conversion factors right. Okay, assuming you get all of the numbers plugged in correctly and everything. All right, so if you set up the problem right, that is the major part of these problems. It's just learning how to set it up correctly. And we're going to go over this in class as well, and I'll show you more what I mean of like ignore the numbers. Okay, so for an example, we have 2.34 feet in meters. Okay, so we have our unit conversion factor here. It's 1 foot equals 30.48 centimeters. Okay, so we're given feet and we need to get it to given feet, we need to get it to meters. And then we're given our unit conversion factor in centimeters. Okay, so this is actually going to be a two-step conversion. So we're given feet. We need to cancel feet and take it to centimeters, which we can do here. So this feet will be on top. So this foot has to go on the bottom. That will cancel. Okay, so your feet will cancel. I know it sounds bad, but it's not. And then that will leave you with centimeters. And then because we have centimeters and that's in the metric system, you can easily convert to meters. All right? So you can write your unit conversion factor like this. Okay, it's the exact same thing here. And then this is how you write out your problem. Okay, so you have feet on top. You have to make sure that you have feet on the bottom to cancel. Those two will cancel. Then you have centimeters on top here. And then I just use the unit conversion factor. I know that there are 100 centimeters in a meter because that's 10 to the second. Okay, so if you remember, there's the feet cancel. And then the centimeters will cancel. And that leaves you with meters. Okay, so then you multiply everything that's on the top and then divide by everything that's on the bottom. So you would do 2.34 times 30.48 and then divide that answer by 100. Okay, and that's where you get this number, the 0.713232. And then again, units. Can't forget your units. Okay, so that leaves you with your correct answer there. And let's just run through this again here real quick. So the way that I knew to put the 100 in here for the 1 meter and the 100 centimeters, I looked here. Okay, so my base is actually being used. Base number here is meters. Okay, or base units here are meters. And then we've got centimeters here. Okay, so centimeters are 10 to the negative 2, which means that you're going to have 100 centimeters in 1 meter. Now, if you didn't want to have to deal with putting an actual number in this and you just want to use this scale here to convert that, you would just do the 2.34 times 30.48. That would get you 71.3232 centimeters. Okay, and then you've got centimeters, and you take your decimal point and you move it 2 places to the left to get meters. And you end up with the same answer. Okay, so you can do it either way. It's more kind of comes down to how comfortable you are with the number part of this conversion versus just doing this. Okay, so whichever way is easier for you, go with it. All right, so that's where we're going to stop in this video. In the next video, we're going to cover sig figs.